this video we're going to prepare the very notorious ketone, phenyl 2-propanone, otherwise known as phenylacetone. Because the ketone is reactive and easily substituted and replaced by amines, it's an easy starting point for substances with a phenethylamine backbone, including some popular stimulant drugs. We won't be making any drugs, so don't get excited. But we are interested to see if there's a convenient synthesis route from easily available materials. This reaction involves a highly toxic and lachrymatory intermediate compound. We've found that a good way to handle this relatively safely is by doing the first step of the reaction inside the separating funnel. This minimizes exposure. But to do this experiment you will need serious ventilation, and preferably a face mask and breathing apparatus. Let's get started. First measure out 25 ml of acetone. This is an excess of what we need theoretically, but we use an excess to reduce formation of dihomo compounds in the first reaction. Add this to the separating funnel and make sure that the stopcock is closed and tight to avoid leaks. Now take large beaker containing around 250 ml of water and add sodium hydroxide to create the dilute solution. Around 10 grams is enough. Stir this to dissolve and then allow to cool down. Place this underneath the separating funnel containing the acetone. This is your emergency quench system. In the event that anything goes wrong and you want to stop the reaction, simply open the stopcock and drain the reaction mixture into the beaker, hydrolyzing the dangerous acetone. Now secure a glass tube attached to a hose and place it so that it points down into the separating funnel like this. We'll use this to blow air through the reaction mixture to remove HBr gas. The easiest way to do this is attach the hose to the output of a vacuum pump so that it's blowing air, and then take the two tubes and put them together when needed. In the first step of the reaction we react the acetone with bromine to create acetone. We're going to use the solution of bromine in dichloromethane that we prepared in another video. This works well because the dichloromethane will then also act as a solvent for our product, and the bromine is dilute enough not to react too vigorously. We measured out 33 ml, which corresponds to 27.5 grams of pure bromine. Place this into a flask which will avoid evaporation, and prepare a dropper. Make sure at this point that you have very strong ventilation running. We're ready to start. Take 1 drop of the bromine in dichloromethane solution, and add it to the acetone in the separating funnel. You'll see the color go orange to begin with. The reaction is acid catalyzed, and as the bromine reacts with the acetone it generates hydrogen bromide, which is acidic. So the first drop takes the longest to react. Now that the solution is acidic, subsequent drops react much faster. Keep adding the bromine solution dropwise so that you don't allow any color to build up. You will see a slight yellow color appearing in the solution, but this is okay. At this point use the air blower to blow out the hydrogen bromide smoke in the funnel. And then continue adding the bromine solution. The mixture will warm up and you'll start to see acetone refluxing in the funnel. Allow to cool for a few minutes or apply an ice pack if you need to. And occasionally blow out hydrogen bromide as it accumulates in the funnel. Complete addition take around 40 minutes. At the end the solution has a slight yellow tint. This contains our acetone intermediate. We now need to clean it up a bit. So weigh out 15 grams of sodium carbonate. We're using the anhydrous salt here. Add 50 ml of water and stir to form a relatively saturated solution. Add this slowly to the separating funnel. The carbonate will neutralize excess hydrogen bromide, and the excess acetone should migrate into the water layer. You'll see some effervescence as CO2 is given off. You may end up with some white solid in the separating funnel which won't dissolve. We're not too sure what this is, but if you get this, then add a little more water and swirl the mixture to dissolve. Here we are. The bottom layer should be a solution of our bromoketone intermediate product in dichloromethane. Very carefully separate this into a small flask and then seal the top up tightly. Note that this isn't a stable compound, so you must use it quickly after preparation. Over an hour or so you will start to see the color darken. In order to use this in our next reaction, we have to make sure it's completely dry. So add a small amount of anhydrous calcium chloride to the flask and swirl around to absorb all moisture. You should end up with a nice clear solution. Now take 100 ml of your quench sodium hydroxide solution and add to the separating funnel. This will rapidly hydrolyze any bromoacetone remaining in the aqueous layer. Then dump the contents of the funnel into the remainder of your quench solution. After a few minutes, the toxic bromoketone is hydrolyzed and you can safely dispose of the solution. Now we're going to perform the second step in the reaction. Measure out 50 ml of dry benzene. Again, this is more than we need for the reaction because we want to minimize dual alkylations. Set up a dry 250 ml flask equipped with good magnetic stirrer and add benzene to the flask. Now weigh out 23 grams of anhydrous aluminium chloride. Keep this wrapped up to avoid moisture. For information about how to make this from zinc chloride, check out our other video linked. Add the aluminium chloride to the benzene in the flask with stirrer. We had a slight yellow color on complete addition, but we're not sure why. Now set up the flask with an addition funnel. If you don't have a pressure equalized one, you'll need a way to vent gas produced. Add the bromoacetone solution in DCM to the addition funnel, making sure that the tap is closed. You can already see that the color has changed due to some decomposition. Now begin the very slow addition of this to the vigorously stirred benzene mixture in the flask. A lot of hydrogen bromide gas is going to be produced and the temperature will increase. Don't allow the temperature to rise above about 50 degrees C. You will see an orange color and then the mixture will become dark. Make sure you have good ventilation because a lot of gas is going to escape from the reaction mixture. If the temperature starts to rise too much, stop addition and use a water bath or an ice pack to cool the flask. Complete addition takes around 40 minutes, after which allow the mixture to stir for another 30 minutes. During this period you can dismantle and carefully wash the addition funnel using dilute sodium hydroxide solution. After 30 minutes of stirring, take the solution and carefully add it to 60 grams of ice and 5 ml of concentrated hydrochloric acid in a large beaker. Then stir the mixture well and allow to settle. The top benzene layer contains our product, so pour the mixture into a separating funnel. Allow the layers to separate well and then separate off the bottom aqueous layer. You could extract this further with a small portion of benzene if you wanted to. Now make up a solution of 4 grams of sodium hydroxide in about 60 ml of water. Add this to the funnel and give the mixture a shake in order to remove any toxic residual bromoketone. Let the layers separate and then remove the bottom aqueous sodium hydroxide layer. The organic layer should now be free of lachrymatory effects. Now pour the organic top layer into a 500 ml flask and add 200 ml of water. We're going to steam distill out our ketone product, and you'll need another portion of water later on during distillation because it takes some time. Set up for distillation. First of all, a little dichloromethane will distill, and then the benzene mixed with a small amount of water has the acetone. Here's the benzene and water coming off. Don't try to separate fractions, just collect everything into one flask. Once the benzene has finished, the product will start to steam distill along with the water. This is fairly slow and takes 2 to 3 hours. You may need to top up the boiling flask with water. The product has a yellow tint and you can see it dissolving in the benzene layer in the collection flask. At the end of the distillation there's some brown gunk left in the boiling flask which can be removed with a little acetone. Here's the distillate we collected. Around 325 ml in total. Pour this into a separating funnel and separate the bottom aqueous layer. Reserve this. Then collect the benzene layer in a small flask. Return the aqueous layer to the funnel and extract it using 10 ml of benzene. Then separate the aqueous layer and combine the benzene layer with the previous one. Dry using a small amount of anhydrous magnesium sulfate. We then set up for vacuum distillation. The benzene came off rapidly and we recovered this. Collecting 37 ml of benzene, possibly with a little DCM in there. Then the temperature rose and the yellow oil remaining in the flask began to distill at around 130 degrees C. We collected a small amount, but then problems struck. Decomposition. The contents of the boiling flask started to turn black. We salvaged the oil collected to that point and stopped distillation. We got 3.1 grams of the yellow oil with a very interesting aroma. Sweet and somewhat similar to propanone, but without the spiciness and with a slightly more pine needle and Christmas tree overtone. If this is phenyl acetone, then it's a 14% yield from bromine, the limiting reagent in the reaction. This isn't great, but actually we're quite surprised that we got anything from this. The pot still contained a little bit of oil as you can see. We're not sure what caused the decomposition though. This has the same strong smell as the distillate, so perhaps some more product can be obtained from this. Overall we're impressed that this did actually produce something, although we've yet to confirm that this is in fact P2P. That said, the complexity of this preparation, the very low yield and the highly toxic intermediate mean that we can't really recommend it. We might try this again using iodine, but be warned that iodoacetone is even more strongly lacrimatory than the bromo version and we expect that this may be impossible to handle. Thanks for watching and please stay safe with these more complex procedures.